Hello everyone and welcome back to PostNetwork Academy. I am Bindeswar and in today's video we will deep dive into negative binomial distribution, intuition behind, real life examples, derivation and formulas. All I will cover in this video. So without further delay, let's get started. So basically the negative binomial distribution, it is a generalization of geometric distribution, and I have also made a video on geometric distribution. So basically this is a generalization of geometric distribution, and basically it describes the number of failures, the RH success in a sequence of Bernoulli trials. Means the number of failures before the RH success. This is the main concept. This kind of events basically negative binomial distribution models. And when R is equal to 1, so it reduces to geometric distribution. As I have discussed that negative binomial distribution is generalization of geometric distribution. So let us define random variable. So let x denote the number of failures. Remember, if you want to understand any probability density function or probability mass function, just understand what x is. So in this case, x denotes the number of failures before the RH success. And each trial has probability of success, we will denote it by P, and probability of failure by 1 minus P, or it is also denoted as Q. And then x takes values 0, 1, 2 and these so on, these discrete values, and basically we are interested to calculate probability when x has some value, and the probability of observing x failures before RH success. This is what x is denoting. So to have x failures before RH success, understand here it is very important, the last, that is means x plus r, trial must be a success, and the previous, that is x plus r minus 1 trials must contain r minus 1 successes and x failures. So this term means x failures and r minus 1 successes, and the number of which, that means here you will understand combination, number of which arrange x minus r minus 1 successes in x plus r minus 1 trials. So you will denote, means here it is also denoted in C x plus r minus 1 and r minus 1. This is the symbol. Means number of which to arrange r minus 1 successes in x plus r minus 1 trials. You will denote it by this one. We will use, and probability of getting x, that means here what x denotes I have already explained to you. So let us see the probability mass function of negative binomial distribution. It is denoted as x plus r minus 1 r minus 1. This is also denoted as x plus r minus 1 c r minus 1, and that part as it is. So 1 minus p, where p is probability of success in each trial. Probability of success in a single trial means each trial. 1 minus p probability of failure, r number of required successes, and this is the main, you can say that element of PMF. So number of ways to arrange r minus 1 successes among x plus r minus 1 trials. So let us see the mean and variance of random variable x. So for the binomial distribution, the probabilities x is equal to 0, 1, 2 are the successive terms of the binomial expansion q plus p raised n. So we can derive them using the concept of binomial distribution. So mean of binomial distribution, that is np, and variance npq, a binomial distribution, not negative binomial. So this represents the product of the index n, the second term in q plus p here, the index n and the second term. You can see that here. So we will also use the same concept. So here for negative binomial distribution, the probabilities are successive terms of 1 plus p, p upon q upon p raised r. So that term we will use. See that? Minus r means index and the second term, this one, p upon q. So minus r and this minus q upon p, and if you multiply them, rq upon p. See that this can also be explained in detail, and probably I will make one video if you have any problem, but very easy. You can compare them with binomial distribution, and you can see that these are family of binomial distribution, whether it is hypergeometric distribution, negative binomial distribution, or geometric distribution, even Poisson distribution, all are, you can say that, variant of binomial distribution. Now the variance, again, minus r minus q upon p, 1 plus q upon p mp. So variance would be rq upon p square. You can also try to derive. You can also use variance of x e expected value of random variable x square minus expected value square. You can also use that formula and you will get the same result. Now let us see some examples. So example 1, find the probability that the third heads turn up in 5 tosses of an unbiased coin. And this is a negative binomial distribution problem. So here success probability is 1 upon 2, and number of successes, third successes, 3 successes. So how many trials? So x plus r, that would be 5, and this implies x is equal to 2. So failures before third success. So x is equal to 2. And use the negative binomial distribution probability mass function and just plug the values. So 4 C2, 1 upon 2, Q is also 1 upon 2, and here there is 3 and this one 2, and finally you will get 3 upon 16 if you plug and solve all the values. Now example 2, find the probability that the third child in a family is his second daughter. See that here again, P half, because half probability of boys and half is daughter. So probability is half, 1 upon 2. Now this is again a negative binomial distribution problem, and we can model this problem using negative binomial distribution. P, that is 1 upon 2, R second daughter, that means R, you are modeling daughter's birth as a success, so 2 daughters, second daughter. So x plus R is equal to 3. So third child, so x is equal to 1. Now just plug the values, and if you plug the values, so we will get 1 upon 2. Just plug the values. After finding x and r and p, 3 variable are, you can say that values if you find, you can plug and you can find the probability. Now example 3, a proofreader catches a misprint in a document with probability 0.8. See that here, probability you have got. Thereafter find the expected number of misprints in the document in which the proofreader stops after catching the 20th misprint. See that here, the number of misprints not caught by the proofreader, that is x. See that it is defined here what is x. So let r be the number of misprints caught by the proofreader, and thereafter r would be 20. So p is already 0.8, so q 1 minus p, So 0.2. So we will model X by the negative binomial distribution, counts of failures before rth success. So here, that is negative binomial distribution, we have derived expected value. So R we already know, Q will plug, and P 0.2 and 0.8, and just plug the values and you will get 5. Expected value of random variable X, that is 5. And the expected total number of misprints when proofreader stops after catching the 20th, that is expected value of X plus R. And you know that expectation operator is distributed, it can be distributed, so it is distributed. So expected value we have got 5 and R 20, so 25. So thereafter the expected number of misprints is 25. Let us see another example. An item is produced by a machine in large numbers, and the machine is known to produce 10% defectives. That means probability is 0.1 and 1 minus P is 0.9 or Q is 0.9. And the quality control engineer is testing the items. You can see that negative binomial distribution can also be used in quality testing. So we are to find the probability that at least 3 items are examined in order to get 2 defective. For this one, let us understand or find out R and X. So this is negative binomial situation where R is equal to 2, P is equal to 0.1, Q is equal to 0.9, and X here, what we need to find out, X plus R, that should be greater than or equal to 2. Or equivalently, you can just, if you solve, so you can get this one, means X is greater than or equal to 1. So just for the negative binomial distribution, you know that the probability mass function, X plus R minus 1, R minus 1, P raise R and Q raise X. So greater than 1, so this can also be expressed like 1 minus P, X is equal to 0. So for X is equal to 0, we will find the probability and just we will subtract it by 1. So we will get this value 0.01. Therefore 0.099. So we have subtracted, that means this value, as I have explained you. So we will get 0.99. So thereafter probability that at least 3 items are examined to get 2 defects is 0.99. Let us see in last example. So a family stops producing children after having the second daughter. Right? Again, each child is equally likely to be male or female. That is the probability half. One similar kind of example I have explained. But let us see, this is a little bit different. So X be the number of boys before the second girl is born. So R is equal to 2, number of daughters, probability of daughter, probability of son, half, that is probability of half, probability is half. So expected number of boys, RQ upon P, so 2 into half upon half, that is 2. And total expected children, X plus R. So expected value of X, expected value of R would be R. So 2 plus 2, that is 4. So you have understood negative binomial distribution, its mean, variance and some real life examples. Now you can also understand where other areas where negative binomial distribution can be applied. So modeling of failed trials before fixed number of successes, used in quality control as I explained you, applied in ecology, insurance claims and health studies as well. And generalizes the geometric distribution for multiple successes. So this is basically generalized version of geometric distribution. So hope you understood, and for more resources you can visit www.postnetwork.co, YouTube channel and handle is @ PostNetwork Academy, Facebook page, that is page PostNetwork Academy, LinkedIn page, again company page, you can visit PostNetwork Academy, and GitHub, the same name, PostNetwork Academy. So hope you understood and you will support my channel, pages and website. So thanks for watching the video.